All right, today we are talking about special products of binomials, and your essential question is, what are the patterns in the special products a plus b times a minus b? So we're going to talk about this one. So what happens when you have a binomial that's plus and a binomial that's minus and you multiply them together? And then what happens if you take a plus b squared? And what happens if you take a minus b squared? So there's three different types of special products that we're going to talk about today. All right, so take some time for just a second. Go ahead and pause the video and multiply out these two examples and then see if you notice any patterns. Okay, so if you multiply out the first one, we take x times both numbers. So we have x times x, which is x squared. And then we have x times negative 2, which is negative 2x. And then we have to take 2 times both numbers. So 2 times x would be positive 2x. And 2 times negative 2 would be negative 4. Okay, then we can combine our like terms in the middle. And negative 2x plus 2x actually just cancels out. So then we're left with x squared minus 4 as the answer for the first one. Okay, for the second example, we're going to do the same thing. So we take 2x times both numbers. So 2x times 2x is 4x squared. 2x times 1 is positive 2x. Okay, then we're going to take negative 1 times both numbers. So negative 1 times 2x would be negative 2x. And negative 1 times 1 would be negative 1. And again, what happens is the middle ones cancel each other out. And so we're left with 4x squared minus 1. So on both of these examples, we had the same numbers. We had x and 2 in both positions, but one was plus and one was minus. And then here, we had 2x and 1 on both ones, but one was plus and one was minus. So what happens is anytime you have an example like this where you have one, this is like the pattern for this is a plus b times a minus b. What you get is called a difference of squares. That's because this number right here is a perfect square. This is x times x. And this number here is 2 times 2. So if you take this one and you square it, you get x squared. If you take this one and you square it, you get 4. And it always ends up being minus, so that's why it's a difference of squares. Same with this one. I took 2x times 2x, so this is a perfect square, 4x squared. And I took 1 times 1, and I got 1. The middle part always cancels out. So there's a pattern that you can use as like a shortcut. Now, if you're not comfortable with using the shortcut, then you can always just go ahead and multiply it out just like we just did and get the answer just to double check. Okay, so this is, again, called a difference of squares. They call it a sum and difference pattern, but it's more commonly called a difference of squares. So you have two numbers that are squared, and we're taking the difference. And so when you have two numbers that are the same, but one's plus, one's minus, you end up with a difference of squares. The middle part cancels each other out. Okay, so here's your chance to practice the shortcut. Okay, we're not going to multiply the whole thing out. We're just going to use the shortcut. So I see that I have t and 5 and t and 5, but one is a plus and one is a minus. So I know that the pattern is to take t and square it, and subtract, and take 5 and square it. So what happens is I get t squared minus 25. And if you're not comfortable with that, then go ahead and just multiply it out using double distribution or the stacked method or whichever method you are used to, FOIL, whatever you want to use. Okay, let's try this one using the shortcut. So again, we have 3 and y, or 3x and y, and we have 3x and y, so they're the same numbers. One's a plus, one's a minus. So I know I'm going to take 3x and square it. And then I'm going to subtract, and I'm going to take y and square it. Now you'll notice on this one I put the 3x in parentheses because if I take 3x times 3x, I don't just get 3x squared. What happens when I take 3x times 3x? I get 9x squared. So that's why I put that one in parentheses. Okay, and then I have minus y squared. Pretty cool. All right, now we are squaring binomials. So when you square a binomial, there's kind of a pattern for that also. So when you square something, what does that mean that you're really doing? Well, it means that you're multiplying something by itself. So this needs to be written as 3x plus 4 times 3x plus 4. It's the same thing. Okay, and I can go ahead and multiply this out. So I'm going to take 3x times both numbers. So 3x times 3x equals 9x squared. 3x times 4 is positive 12x. Then I'm taking 4 times both numbers, so 4 times 3x would be positive 12x again. And 4 times 4 is 16. Now, feel free to pause the video anytime and work these out on your own and then just check your answers. Okay, then from here we can combine our like terms in the middle. So we get 9x squared plus 24x plus 16. So this is our answer for the first one. Okay. Go ahead and pause the video if you want and work out the second one, and then you can follow along. Okay, so again, because we're squaring it, we're going to rewrite it as multiplied by itself. So 5x minus 2y times 5x minus 2y. Okay, so we're going to take 5x times both numbers. So 5x times 5x is 25x squared. 5x times negative 2y would be negative 10y. Okay, then I have to take negative 2y times both numbers. So negative 2y times 5x would be, again, negative 10y. And negative 2y times negative 2y would be positive 4y squared. So again, I can combine the like terms in the middle, and I get 25x squared minus 20y plus 4y squared. Okay, now if you take a close look at these, there are patterns that happen on both of these examples. Okay, I'm squaring it, right? So I always take the first one times itself, right? So really it's like I took the first number and I squared it. So we'll call this number A and we'll call this number B. Okay, so for this one, I took A and I squared it. I took this number and I multiplied it by itself. Okay, then what I did was I multiplied the 3x times the 4. So I took A times B, and I actually ended up doing that twice because I took 3x times 4 here, and then I took 3x times 4 here. So what happens is I got plus 2 times A times B in the middle. So I took this number, I multiplied them together. 3x times 4 is 12x, but I did that twice. So there's 2 A times B's. Okay, then I took the last number, 4, and I multiplied it by itself, 4. So I squared that number too. So that would be like I did B squared. So this is actually the pattern for any time that you square a binomial and it is a plus in the middle. It's positive. Okay. And it's the same pattern for this one, except for you'll notice one difference. This one is a minus sign. So if you have a minus sign here in the middle, you're going to end up with a minus sign here at the end. So again, if you look closely at the pattern, okay, this time I took 5x times itself. So like if this one is A and this one is B, okay, I took 5x times 5x. So I took A squared again. Okay, and then I took a times b. I took a times b, 5x times negative 2y, and I got negative 10y. And then I did that again. I multiplied those two numbers together again, so I got another negative 10y. So I have minus 2, and they multiplied these together, so minus a 2ab. Okay, and then I took the last number and I squared it, and when you take a negative times a negative, it always turns out positive. So this one becomes a plus b squared again. So it's the same pattern both times, just this one is a plus because there's a plus in the middle, and this one is a minus because there's a minus in the middle. Okay, so if that is super confusing to you and you are totally lost right now, you do not really have to apply these formulas. You can just rewrite it like we did and multiply these out using FOIL or double distribution or the stacked method or whatever one you like, and just work it out. So don't freak out if you are totally lost. It's okay. So again, here's the pattern. Okay, if we have a number like this where it's plus in the middle and we're squaring it, then this is our formula. If it's minus in the middle and we're squaring it, then this is our formula. So here's an example that they did over here. Because I'm adding, I take a squared, so I'm taking this number squared, so I get x squared. And then I'm taking 2 times a times b. Well, if this is a and this is b, then I'm taking 2 times a, which is x, times b, which is 5. So I have this. And then the last thing was to take b and square it. So I have 5 squared. So if I work that out, then I get x squared. And then 2 times x times 5 would give me 10x. And then 5 squared is 25. So this would be the answer. So it's kind of like a shortcut for multiplying these, but you don't have to do it this way. Okay. So same thing here. If I'm subtracting and squaring it, I'm taking a and squaring it. So I'm taking 2x squared. And then I'm taking minus, so minus 2 times a times b. So 2 times a, which is 2x, times b, which is 3. And then plus b squared, so plus 3 squared. So if I work that out, 2x times 2x gives me 4x squared, then minus. And then I take 2 times 2x, which would be 4x, times 3, which would give me the 12x in the middle. And then 3 squared is 9, so this would be the final answer. Alright, so let's try to apply that shortcut one last time. So remember, it was a squared plus 2ab plus b squared. So that was our formula. Okay, so if we work this out, this is a, this is b. Okay, I'm using the shortcut. If you don't like the shortcut, then just rewrite this twice, do x plus 2 times x plus 2, and find the answer. Okay, you'll get the same thing. So if I take a squared, then I'm taking x squared plus, and then I'm taking 2 times a times b. So I'm taking 2 times x times 2. 2 times a times b. Then plus b squared, which is 2 squared. Okay? So here's what I get from that. After that, if I work this out, then I get x squared, and then what's 2 times x times 2? That gives me 4x, and then 2 squared is 4. So if you were to just multiply it out the long way, then you should end up with the same answer. Okay, let's try this one. So this one is the same pattern, but instead of having a plus, I'm having a minus in my formula. Okay, so this is a and this is b. So I'm taking a squared, so 2x squared minus 2 times a, which is 2x, times b, which is 1, and then plus b squared, 1 squared. And you don't have to put all these in parentheses, or you can put them in the parentheses. Like I could have put parentheses around this and around this if I wanted to. It doesn't matter. Okay, so then from here, 2x times 2x gives me 4x squared. Then I have minus, then 2 times 2x times 1 would give me 4x. And then 1 times 1, or 1 squared, is just 1. So this would be the answer using the shortcut or the long way, whichever you choose to do it. All right, so you can go back to the essential question and write your summary. Thank you.